Welcome to a video on quadratic functions. In this video, we'll learn how to find the domain and range of a quadratic function. We will also be using the technology Desmos. Let's get started. The domain of a function is a set of all possible values for the input or independent variable. This is usually known as x for a function. The range of a function is a set of all possible values for the output or dependent variable. This is most commonly known as y. The domain describes the x values, which is the horizontal variable in a graph. The range describes the output variables, which is the vertical values of a graph. Let's take a look at our first example. We want to find the domain and range for the function f of x equals x squared minus 2x plus 3. I have part of the graph here for us. First, let's just recall how a function works graphically. For every point xy that's on the graph of a function, there is a corresponding x and y value that make up those coordinate points. So for example, if the point 2, 3 is on this graph, then the x value is 2 and the y value is 3. That means that 2 is in the domain since it's the x value, and 3, which is the y value of that point, is in the range. 2 is one point that's in the domain, but we want to know all the points in the domain. So keep in mind the domain are the x values. And likewise, 3 was in the range, but we want to know all the values in the range. So the range are the y values. Keep that in mind as we go over to Desmos and look at this graph in depth. You can find a link to the Desmos graph in the description of this video. I've opened this graph using Desmos, and I've added some features where we can drag these points along the graph. We know that this point 2, 3 is a part of the function's graph, which tells us that 2 is in the domain and 3 is in the range. If we're looking for other values, we can simply drag this point along. As you can see, as the coordinates of this point changes, every x value of a point that is on our function is in the domain. Every y value of a point that is on our function is in the range. So what you should be seeing here is that there are a lot of points in the domain and range. In fact, there are actually too many to list. If I wanted to list every point in the domain, I would have to list every single possible x value. 2.8, 2.83, 2.85. Obviously, making a list does not make sense. This is where we're going to use interval notation. I just need to know which points are in our domain. It looks like I can keep dragging this point. All of these x values tending toward positive infinity are in the domain. If I unlock the viewport, I can use my mouse or the plus and minus buttons on the upper right hand side to zoom out. When I zoom out, I can see a much larger picture of the graph. It looks like all of these x values as x goes toward positive infinity are in the domain. And if I move the point toward negative infinity, we see that all of these x values are also in the domain for the function. So the domain for this function is all real numbers, or in interval notation, we would write that from negative infinity to infinity. That just means that every single x value will correspond to a point on the graph of this function. For the range, we're looking at the possible y values. As I drag my point along the function, I can see that all of these y values are a part of the range. It looks like when we get to a y value at 2, it turns the corner and starts to go back up again. So the y values go up toward positive infinity, but unlike the domain, the y values stop at positive 2. That's also because positive 2 is the y coordinate of the vertex, and that is the lowest point on this quadratic function. To summarize, our domain was all real numbers. Using interval notation, we would write that as a negative infinity to infinity. There are no restriction on x values. X could be anything for this function. The range or the output values are limited to values between 2 and infinity. That's because 2 is the y-coordinate of the vertex. That's that lowest point, and then the y values only get bigger from there out. Let's take a minute to review interval notation. We use different types of brackets to denote which points are included or excluded in the domain and range. To show that a point is included, we use square brackets. Graphically, to show points are included, we use solid dots on a graph. To show that points are excluded, we use round parentheses. Graphically, we use open dots to show that points are excluded from the graph. Keep in mind that negative infinity and positive infinity always get a round parenthesis since they can never be included. That's because they are not real numbers. We're looking at the function f of x equals negative 2x squared minus 6. We want to determine the coordinates of the vertex and the domain and range. And let's go over to Desmos and draw this function. Now that we're back in Desmos, let's open a new blank graph and enter our function. Go up to the 3 lines on the left-hand side and choose New Blank Graph. In the first cell, type in your function. I've entered the function f of x equals negative 2x squared minus 6 into the first cell, and Desmos has graphed it on the axis provided. It looks like I need to adjust the graph settings to see a better picture of the graph. To adjust the graph settings, you can use the zoom in and zoom out buttons on the upper right hand side, use your mouse to scroll in and out, or click on the wrench and set the graph settings. I'm going to go ahead and use my mouse to scroll out and move the graph around so I can see it a little bit better. Let's find the coordinates of the vertex by clicking on that point. It looks like our vertex is 0, negative 6. It also looks like that is the highest point on this parabola. That will come into play when we find the range for this graph. Once again, if we're looking for the domain, we're looking for all possible x values. If I use my mouse to trace the curve, I can see that there are a lot of different x values that make up points on this curve. In fact, just like the parabola before us, the domain for this function is going to be all real numbers. Every single x value will correspond to a point on this function. You need to imagine that this parabola, it keeps going down, but it also keeps spreading out from left to right. So eventually we would get to x values that are very large. As I trace this curve for the y values, all of the negative y values are a part of the range up to negative 6, which is the vertex, and then the curve turns the corner and goes back down again. So the range for this function is from negative infinity up to negative 6, including negative 6, since there is a solid dot on the graph at that point. To summarize, we found the coordinates of the vertex to be 0, negative 6. The domain was all real numbers, which is negative infinity to infinity in interval notation. And the range was negative infinity to negative 6. And I'm using a square bracket on negative 6 because that point is included in the function. Finally, let's determine the domain and range for this graph. This graph has a limited domain and range. Essentially, pieces of this quadratic function have been cut off. So if I want to find the domain, I'm looking for the horizontal or x values that are used. So it looks like the horizontal values for this function span between negative 2 and positive 3. Since there is a solid dot at negative 2, negative 2 is included in the domain. Since there is an open dot at 3, 3 is excluded from the domain. So the domain for this function will be everything between negative 2 and 3, including negative 2 with the square bracket, and excluding 3 with a round parenthesis. To find the range, we're looking for the y values that are used. It looks like the range for this function is everything between negative 5 and 4. Since there is an open dot at the point 3, negative 5 is excluded from the range. 4 is included in the range since there is a solid dot at 0, 4, which would happen to be the vertex for this parabola. So the range would be everything from -5 to 4, excluding -5 because there's an open dot down there, including 4 since there is a solid dot at 0, 4. That's it for this video. Thanks for watching.